So, what if you could audit a nation's entire economy, just like a piece of software? Pop the hood, take a look at the source code, and figure out why a system that once ran at lightning speed is now flashing critical failure alerts. Well, that's exactly what we're doing. We're running a full diagnostic on the national operating system of South Korea.
And this quote right here, this is our core diagnostic. A decade ago, analysts were already warning that the system was slowly overheating. Fast forward to today, and that water is boiling. So the question is, how did South Korea's algorithm get stuck in this really dangerous loop? And maybe more importantly, can the system even be patched before it completely boils over? This slide really gets to the heart of the paradox. From the outside, the user interface looks absolutely flawless. Ranked #1 for innovation. But on the inside, the system is running on failing legacy code, totally riddled with vulnerabilities. It's like a machine that looks perfect on the surface, but is actually on the verge of a catastrophic failure. Okay, so to really understand the problem, we've got to go back and audit the initial code. The brilliant, but let's be honest, deeply flawed architecture of what's known as the developmental state. This was the OS that was designed for one thing and one thing only, a national economic speedrun. Think of this as version 1.0 of the OS. The state wasn't just some passive regulator, it was the lead programmer, the system architect. It wrote every line of code with one single objective: catch up to the rest of the world and do it faster than anyone thought was possible. And here's basically how that algorithm worked. Step 1, the state grabbed total control of all the capital. Step 2, it hard-coded these super aggressive export-first incentives. So if you exported, you got cheap loans, you got tax breaks, the whole deal. And step 3, it chose just a few key applications to execute the plan. And these were the Chaebols, these massive family-owned conglomerates that were given just immense power to drive growth. For this OS, speed was literally the only metric that mattered.
But here's the thing about any kind of speed run, right? It's reckless, you cut corners, you blow past warning signs, and you build up a massive amount of what we call technical debt. And sooner or later, that debt always comes due.
And the single biggest piece of that debt was a critical bug that was baked right into the core architecture from the very beginning: Chaebol dependency. These huge companies became like privileged kernel-level processes, basically monopolizing all the system resources, all the capital, all the talent, all the political favor, and just starting everything else out.
Now this diagnostic chart, this shows you the consequences pretty clearly. In most advanced economies, your small and medium-sized businesses, your SMEs, are about half as productive as the big guys. In South Korea, it's just 30%. The system was effectively starving all of its smaller processes, making them dangerously inefficient.
And here's why that is so catastrophic. Those underperforming small and medium businesses, they employ 80% of the country's entire workforce. This isn't just some minor bug. This is a fundamental flaw that threatens the stability of the whole system. For decades, the system just ignored these massive performance warnings. But eventually, the users, the actual people, they started submitting bug reports. Social movements, labor unions, NGOs, they all started popping up like error messages, all signaling this widespread institutional fatigue. They were reporting critical bugs, negative outputs, and growing instability.
And this wasn't a sudden crash, right? It was a really slow burn. You had illegal labor unions in the 70s, then the explosion of NGOs after the democratic movements in the late 80s. Society was constantly pushing back. These were all new inputs that the system was never, ever designed to handle. And it created all this pressure for reforms that the core architecture just kept resisting.
Which brings us to where we are today, the era of the Sisyphean state. The system is now a legacy OS, totally incompatible with modern demands. It's just stuck in this feudal loop, constantly applying these minor fixes that don't address the core problem at all. It is a classic textbook case of reactive patching.
A key symptom of this decay is what's called the planning paradox. See, the old OS was built for imitation. It was built for following a map. But when you get to the frontier of innovation, there is no map. That top-down command and control logic that worked great for building steel mills and ships is completely incompatible with the chaos and uncertainty of creating something truly new.
And this quote right here perfectly illustrates that paradox. The government literally set a target for its AI program to understand film plots by 2020. This is the old algorithm trying to run. It's the state trying to command an innovative outcome into existence. But you can't command creativity. The system is trying to solve a 21st century problem with a 1970s command line.
And the result of this failed compatibility test? It's stark. As of late 2023, there were 124 AI unicorns globally. South Korea, a country that prides itself on being a tech powerhouse, had produced 0. None.
The system resource alerts are flashing red all over the place. AI adoption? Critically low. AI talent? There's a massive shortage. The workforce itself, the actual processors of the economy, is shrinking faster than any other developed nation. And productivity? It just remains stubbornly low. The system is running out of memory, it's running out of processing power, and it's losing compatibility with the modern world.
So after our audit, the final report is, well, it's grim. The original code was a masterpiece for its time, no doubt about it, but it's now causing system-wide failures. And that leads us to the ultimate question.
The conclusion of our audit is really this. The fast follower code that powered South Korea's incredible speedrun is now obsolete. At the global technological frontier, where you're expected to lead, not just follow, that old code, it just doesn't compile anymore. It returns fatal errors every single time.
Which leaves us with this one final provocative question. Can an operating system that was purpose-built for a catch-up speedrun ever really be rewritten for true innovation? Or is the technical debt now so massive that the only solution left is a complete system reboot?